Yes.
Okay.
2 questions, anyhow.
Chapter 7B quiz review.
I don't want to come back home.
I did it the last quiz.
There's a stereotype that women talk a lot. All right, there are 6 problems on this test, only 3 are required. Numbers 2, 3, and 4, as you can see from the quiz review, are all bonuses. And every single one of them has to do with the length of an arc. If you want to know the formulas for the length of an arc, it's in 7.4, right near the beginning in a box. And the curve length will do, which one of the 2 formulas you use will depend on whether your curve is going up vertically or horizontally. Okay? So if you wish to study this and try it out, try a couple problems, those bonus problems, the formulas, I'm getting there, I'm talking all, I'm trying to find it. Okay. There at the bottom of page 413, 413, at the bottom, it says arc length, which is the length of a smooth curve. It's an integral, it's the integral of the square root, and it involves the derivative of the original function, which needs to be squared and added to 1 before you square root it.
Wait.
Yeah, I'm not going to tell you more about it. This is how you find the length of a curve. We skipped 7.4, it's not required, so I didn't do it. But if you want to get these bonus problems, then you need to know those. Number 2 is multiple choice. So is number 4. These are the bonus ones I'm still talking about. If you guess the correct one on number 2, I will give you a point. If you get it right by working on it, I will give you a point. Because it's multiple choice, and it just says this. It says, which of the following integrals gives the length of this curve? And it gives you an equation. You could probably tell which one of these is if you had just that memorized. Without doing any problems at all, you could probably identify which one of these gives the length of the curve if you knew those formulas. So, guessing at it or thinking about it and getting it right because of that, I won't be able to tell because most of the time you either guess it right or I can't see your thinking. Either way, I'll give you a point. Number 3, which is next, is the next bonus one, actually says the length of a curve is given by this integral. What's the equation? So you have to go backwards. They're going to give you the integral, which gives the length of a curve, and you got to look at that and decompose it back into the function. If you want that one, and that one is not multiple choice, you have to give, the answer will be y equals whatever this integral finds the length of. You have to take it back apart to do that one. Number 4 says find the length of a curve, and it involves transcendentals and polynomials all mixed together, so it'll probably involve your calculator some. Maybe not. It says find the length of a curve, and it gives you y equals, gives you the boundary from here to here, and you are to round it to the nearest multiple of 5. And so all of your answers are just numbers that end in 5 or 0. Does that make sense? Because if you round to the nearest multiple of 5, that answer is going to end in 5 or 0.
Oh, right.
That's what I'm saying. Is there are 5 choices, and every choice ends in a 5 or a 0. Okay, those are your bonuses, and that's about all I'm going to say about it. If you want to talk to me about it, discuss it with me or whatever, I'm happy to entertain those one at a time. But that's all I'm going to say as a group. These next 3 that we're going to go over one at a time are the ones that are required. And there are only 8 points on this quiz, which means if you miss one of these, you will likely be in the C or D range for your score. So get these right. Numbers 1 and 5, which are required ones, are both multiple choice. Number 6 is not. So starting with number 1. Number 1 is like a piece of that problem where we were lifting the bucket. That had a leaky spot in it, and we were lifting the rope with it. And I will tell you which part of it. You will be lifting the lifting mechanism, meaning the rope or chain or whatever it happens to be. And what it says is either a rope or a chain, it'll be one of the two, weighs this many pounds per foot. So back to English. If a certain length, and it will tell you the length, of this chain of rope is hanging from the edge of a roof of a tall building, how much work will it take to pull the chain of rope up onto the roof? Do you want to see one?
Yeah.
Of course we want to see one.
Okay.
We got the option, why not take it?
Do you want to do a chain or a rope?
Chain.
How much do you want it to weigh per foot? How big a chain are we talking about here?
Let's do a big
So
one.
like a ship
7
chain.
pounds.
Think about a chain, whatever's in your mind. Think about a foot of it, cutting it off, putting it on a scale. How much do you want it to weigh?
3.5 pounds.
All right. So this chain weighs, and we're talking about a chain here, and we're going to lift it up, and it weighs what?
3.5 is a lot.
3.5 is the best.
3.5 pounds per foot of chain. That's what it weighs. Okay? And we are going to lift it to the roof of a tall building. And the chain is already strung up here and being held on by something. Somebody walks up here to the building. Maybe there's a pile of chain down here. No, that's not going to work. The chain barely touches the ground. There's a certain length. It will give you that length. So the chain, the last link is barely touching the ground right here. And there's probably a pile of it up here already, or something that's attached somewhere or another. Somebody goes up here and starts lifting that chain. And the question is, how much work do they do to get it all piled up at their feet at the top of the building, basically? Following? No, it's just a chain. No bucket, no water, just a chain. Okay, that weighs 3.5 pounds per foot. And let's see what else. Did they actually give you the length of it? They give you the length of it. So under the scenario I gave you where the chain is barely touching here and it's just barely attached up here, and this building is 56 feet tall. Question is, how much work is done lifting it to the top of the building? Pardon?
5,488 foot-pounds.
Maybe. Could be. I haven't done it yet, but that's seems reasonable.
I BS actual number 11. I got it right, so I think I figured it out.
Okay.
The way it was planned.
Okay, you hold on to that number. We'll figure it out and we'll see if you're right.
So we need to integrate from 0 to 56 and 2.5x.
Pardon? What did you just say?
I integrated from me.
Yeah.
0 to 56 of 3.5x dx. And it's in foot pounds because that's the unit we use for the weighted chain.
That's what you did?
But I used like the number 11 thing instead, so it was 0.624x, because that's what it says in the example problem.
Oh,
But I changed the units for this one because it's foot pounds instead of units per meter.
okay. Yeah, the answer will be in foot pounds. You can tell it from this right there. But how do you come up with this? How do you come up with what you're going to integrate?
Your lower limit is 0 because you're starting from the ground, and you can only raise it 56 feet because that's as high as it goes.
Each piece of the chain can be raised at the most 56 feet. We're going to collect all the little bits of force times distance.
So 3.5 is force next distance.
The reason why 3.5 is the force is because force and weight are the same in this instance.
Well, to me, it seems like as you lift more, it would get lighter. So why is it not negative 3.5? X.
Because if this is what the line would roughly look like right now.
Mm-hmm.
If it's just like this, it's just like a reflection of it. If we make it negative, then it starts with more, then it goes out to less, but this is just a reflection, so it wouldn't change the area.
He's saying the area under both of those curves, whether the slope is positive or negative, is the same.
But
Wouldn't really matter.
Can you draw a graph of what's going on with this chain? And you are right, Landon. It's going to get lighter as we pull it up. And it's going to be the first pull that you're doing is going to be the toughest. You get a big old pile at your feet right there. Then this chain doesn't have to be lifted anymore. You do some more, and by the time you get to the top, you're just right.
Yep.
That's what the integral is doing. That's the reason why force times distance is not a constant thing throughout the pull. It isn't. Force gets smaller and smaller and smaller as we do this thing. And that's the reason why we need an integral to collect all the force times little tiny distances, which is this. This is the distance. This is the force. Now, can you draw a picture? This is what eases most people's mind because you're familiar with this. Can you draw a picture of, what I mean is, can you draw a graph of force times distance?
That's an answer.
To me, that would mean that like the weight is heavy.
When you have not lifted anything, what's the force?
That's the maximum force, which is
35
pounds times 56,
Do that.
which is 196.
It is.
It's 196.
Yep.
So this is the force at the beginning when we have lifted it no distance at all. Okay? And then the force when it's all done will be 0, but that will be when distance is what?
Yep. Because that's how many feet.
You all agree?
Yes.
You see what's going on with this? Okay? So if I draw this is what's going on. The force keeps getting less and less and less and less and less because I've got more of the chain piled up at my feet and less to lift. Right? Okay? So what is the equation of this function? It's a line. What's its equation?
Negative 196 over 56 plus 196.
What do you expect 196 over 56 to be?
3.5. Plus X.
196.
Plus 196.
X plus 196. Now that doesn't look like what Parker did.
That's the same thing. Does the-
The area under is the same.
Okay, I get that the area under fits.
This graph just makes more sense visually.
This graph makes more sense with the situation, but his makes sense too because his right here, this function right here that we're integrating there would look like this. The same triangle where this is up to 196. What'd you say, Parker? This is still out to 56, but the slope is positive and it starts at 0. So its y-intercept is 0 and the slope is 3.5. So this equation of this line is 3.5x.
So how would you interpret that graph like?
You wouldn't. All you got to realize is that geometrically speaking, they are the same.
Okay, I see that.
So whichever one you integrate is fine. As a matter of fact, folks, this problem doesn't even require an integral if you don't want to. All it requires is that you find the area under the curve because that is the integral. And the area under that curve is a triangle whose base is 196 and whose height is 56, or whose base is 56 and whose height is 196. It's just the same thing. You don't have to integrate anything, but if you did, it would either be this, which really conceptually on the problem doesn't make sense that the slope goes up, but it's the same area. If you can reconcile that geometrically, you can do this, or you can do this. It's the 196 that you're adding that's going to take care of that so that it comes out positive. Or you can do this, which is this. All those will get you the same thing. So if you're going to show me your work, and you should, so if you, just in case you miss it, if you're going to show me your work, you better give me one of these things to look at in case you miss it. Also, one other quirky thing to this particular problem is it says round your work to the nearest 25 foot-pounds. So every answer has foot-pounds on it. That will be the linear. So the units isn't the issue. And every problem will be some multiple of 25. So you got to round to the nearest 25 foot-pounds. How would you do that on this one? Does anybody have an answer for this? What'd you say it was?
5488. So you've rounded to
5488?
Yeah, rounded to 55.
Yep, 5,500 would be what you would choose because 88 is closer to 100 than it is to 75.
If it was 87, you would round down.
87.5 is the cutoff. 87 would be rounding down. 88 rounds up. What are you closer to? 5,500 or 5475? You're at 18. No, you're at 13 past 75. That's a little more than halfway. So you round up. That's number one.
So you add subtract over the negative. Increase.
Integrate your
Or
Number 5, if you remember the syntax in your calculator, no one misses number 5. If you remember your syntax for a distribution, which is above your vars key, and you use a normal CDF. Do y'all remember doing that?
Oh, is this the, like the?
This is the probability curve, the normal curve for probability.
Can we do one?
Yes, we will, of course. Listen, I will change the numbers in here to protect my test or my quiz, but it'll be the very same process. It says, the mean weight of a certain brand of frozen dinner is 14 pounds. No, that's not true. Can you imagine? Frozen dinner, 14 pounds. Okay, listen. Yeah, wait a minute. The mean weight of a certain brand of frozen dinner is 14.2 ounces. The standard deviation of these packages of frozen things coming off the assembly line, the standard deviation is 0.42. And that's measured in ounces, if that matters to you. It says ounces on here, 0.42 ounces. The question is, what percentage of the frozen dinners weigh between, what did I tell you the mean was? Which weigh between 13 and 16 ounces? And when you find that, round to the nearest 5%. That's what it requires for you to do.
Nearest 5%.
Nearest 5%. All this test, he got hung up on rounding on this test. Everything's rounded. Checking to see if you can round properly.
I got it very close to. Yeah, I got over it. Yeah.
0.997.
If you could point to form set
Now remember, whatever you get on your calculator will be between 0 and 1. You have to change it to a percentage and round it off.
So we're rounding to 100%. 14. How do you get to this one?
Where did I say we were on? The big one was 16.
Tarnation.
So
What just happened? The mean weight was 14.
The mean is that one.
The second one.
Standard deviation.
What was the
And then you do it from
Yeah.
one to
All right, it's not gonna be this, it's not gonna be 99. I went a little far, so I want you to go in and amend it and change the upper bound to 14.5. So from 13 to 14.5, what's the percentage?
U is the mean one, and the O is the difference, 14 ounces.
Okay.
And on that one I get, if I'm rounding to the nearest 5% would be 75%.
Yeah.
If I round it to the nearest 5%. Is that what you got or not?
Yes.
Yep.
I just rounded
Like
wrong.
lowercase.
We rounded wrong.
I went to 80.
Okay.
This.
I will tell you this, your choices on number 5 are only different. You can't make that error. You have to round correctly.
Why?
I don't know how to round it very well. I totally rounded it down.
Okay, no, it's
Dude, I learned how to round in
the
like
worst one
first
is
grade,
the
and I still don't think I'm good at it.
Are we okay on number 5 or not?
I know, but that is just 25, you count.
Wait, what if it's the nearest 10? Just like it's like.
What?
There's to the nearest 10.
No, not if it's.
You just give away the number 2, though, so one of
And it'd be
those.
0.495,
Okay, I was wrong.
but that's the same thing if you go to the nearest 100.
I don't know what's going on, Devin, just hang in there.
Very.
We're trying to figure out how to round.
I realize that, but I don't know what you're talking about, so I'm just waiting.
I hate to see it.
No, I never did that actually, so I'm like, this is nothing like.
Are we done learning how to round?
Yes.
So you switch it.
Moving along. Last problem that you have to do calls for finding total force on a certain shaped plate submerged in a certain density fluid.
Easy peasy.
The shape of the plate will either be a rectangle, a semicircle, or an equilateral triangle.
Oh, I need the letter.
And I will not tell you which one. If it's the equilateral triangle, I will tell you it is submerged point down. So that one side of the triangle will be at the surface of the fluid. Point down.
Is it?
If it's an equilateral triangle. If it's a semicircle, it will also be, diameter will be on the surface. So you're gonna take it like this and submerge it and find out the force on the plate. Of course, if it's a rectangle, you're just gonna submerge it and it'll just be a rectangle in there and the surface will be on the top side of it.
We should try the equilateral triangle.
Now, would you like to, just for fun, dip this into olive oil? And we learned in olive oil when we were doing the chapter, that olive oil has a density of 57 pounds per cubic foot. Yeah, that's an important thing to know. So we're gonna put this thing in olive oil, and here's the tank. And by the way, this one is not multiple choice. So here's the tank, here's the oil surface, and we are going, which one, do you wanna do all three?
Yes.
Let's start with
I
equilateral.
would spend the next 39.
You wanna start with the equilateral one?
Yeah.
Okay,
Hardest to easiest.
an equilateral triangle, I'll draw it in here, it's gonna be like that.
That's one.
Submerged in there. And let's say that the side of the equilateral triangle is steel, it's a steel plate. I don't care what it is, we're gonna submerge it in it. And the side of it is 8. 8 what? 8 inches. Yeah, okay. And we want to know what the total force is on this triangle. Do you remember your force equation for this kind of a scenario? You'll have to know it because it won't give it to you.
Yeah.
Force is equal to
Pressure times area.
pressure times area, and it's area of a strip. If you just do area, you're going to screw it up. And pressure is equal to, if we bust that down, is equal to weight density times
The depth.
depth, which we are going to call Y because depth is a vertical thing, times the area of the strip. Now, to do these problems, you need to understand why we're numbering it the way we do it. It's counterintuitive from what you've learned in all of math, but this is physics. We're applying math to it. The pressure right here at the surface is 0. The pressure is greatest down here at the bottom, right there. And that distance will be, does anybody know?
8.3 or 4.3.
4/3. Are the rest of you freaking out on me? How'd you get that?
We have to figure out ourselves.
It's the 16.
Yes.
If you draw this depth from here, right straight down to here, you have drawn an altitude and created a 30, 60, 90 for which the short leg is 4.
Yep.
The long leg is the depth. Do you see why we got the 4/3? And we're going to call it positive 4/3 because positive pressure. The most pressure is here and it'll be positive pressure. So we're actually going to number from the top down from 0 to a positive. Don't let that bother you. That's the way we're going to handle this one. Yes.
So will that height be 1/2 base root 3 then? Yeah.
Will that what?
1/2 base root 3. In this case, it's 4 root 3 because half base 4.
1/2 the base root 3. Yep. 1/2 the side length root 3. Y'all see where it came from? Okay, so we have our weight density, which is 57. We have our depth, which is what? What are we talking about? Depth of what? Depth of a strip. The integral will collect the strips when we're ready. But the depth of the strip is how deep is that strip? Why? Every strip is wide, deep, as long as we collect the strips from 0 to 4 or 3.
The 57 is just oil.
Yeah, it's the density of the oil, and that will be given. Whatever they're dipping it into, they'll give you the density. Okay? So our depth, which is y, is y. Now it's the area of the strip that gives everybody trouble. The area of this strip will be its length, dy. I'll stick the dy back here. It's length times width. It's the length that always throws people off. What's going to be the length of every one of these strips? They're all going to be different. Express them in terms of y.
Well, it can't be more than 8.
Nope. Can't be more than 8, can't be less than 0. But it will range between the two.
But
What do we take minus y?
but why is y relevant?
Yeah, I was like,
Because that's how far down you go, and that gives you the height of that triangle. Which times the base of it. Oh, okay, because you got 2 triangles.
So that would be, it'd be like 4 root 3 minus y.
No, depth is just y. We're trying to find the length of the strips.
Yes.
Well.
Let me give you a bit of a hint on how to go about this. Would it be nice to know how long this much of it is?
Yes.
Yes.
Then the other one will be- Yes.
Divide by root 3.
Is that, are y'all stuck or are you still thinking?
Brent is going.
Minus y.
Would it be nice to know the equation of this line?
One half that.
And if you want to write the equation of this line, we're going to need to know where we want to put the origin so that we know how to write it. Where would be a great place to put the origin?
The surface of the triangle. At the point.
The point would be great because we've already got a height which will serve as a y-axis. And if we put the x-axis here on this, then my cross point, my y-axis cross point can be 0 and I'm only worried about the slope. You see what I'm saying? So what's the equation of this line? What is that slope?
See how long.
I'm hearing murmurings that sound like they're right, but be confident. What's the slope of this line? 2x?
Yes.
Really?
No.
Yeah, you go up 4 root 3 over 4.
4 root 3 over 4.
Which is? Root 3.
You go up 4 3 and over 4.
It's rise over run. It's back to the basics. The slope of this line, if we put the origin here, the slope of this line is rise over run. That's another point on the line right up here. You rise 4 root 3, you run 4. 4 root 3 over 4 is root 3. That's the slope of this line. You following?
Yep.
Would that be the slope of the line if it were any equilateral triangle of any length?
Yes.
Yes. Might be a nice thing to remember. Okay, so how do we use this, which we all agree on now after much discussion and gnashing of teeth? We agree that this is the slope of this. If we put the origin at the point, how long is it from here to here? I'm hearing it. What?
Y over root 3.
Yeah, y over root 3. That's the length of it. You're going, what? Isn't the length of this piece from here to here the same as the x value from here to here?
Oh, I'd say so. Listen to him over
And this is x, and x is y over root 3. What?
No,
Yeah. Oh, no. Hurry on a little slower.
okay? So the length of our strip, which goes right here, is going to be 2y over root 3. Do you see that? Okay, now we're ready to integrate. Integrate from where to where? 4 root 3. 57 times 2 divided by root 3 would be 114 over root 3 y squared dy. The integral's not too bad. It's this that is killer. You got to do a lot of math to figure out how you're going to find the length of that strip. That's all around it.
Except for all the not being. Yep.
I got Sid.
Trying to figure out this integral that we spent the last 15 minutes trying to write.
We're doing the computer.
Recording.
Oh, okay.
And the reason it's up there is because the glare on the board when it's down where they are is so horrible, it's hard to watch.
All right.
The glare's off the board when we're done. We're sending it to Devin Bird, who left us but wants to finish the course. There you go.
It worked out.
In Montana. He got homesick and left, but he wants to finish the course at ISU, so we're sending him videos of what we're doing. Yeah. Check with your neighbors and see if you agree. See if you put it in right.
My calculator's better.
Senior sulfur edge. Because you're giving out why value, that's the why. You're just trying to find out.
Pressure equals.
So you just gotta.
Weight density.
How far? How far?
Today.
Oh, okay, right there. That'll give you the length of the strip or multiply too, right?
What time do you go do that?
Yeah.
Yeah, I generally leave about 20 after I have to be there. by
Okay,
9.
let me know if I can.
7,000.
So essentially just.
Yeah, then it's-
Yeah, and then.
Weight density is constant. This is weight density.
I'll have to miss some 4th hour, but I can do that.
So.
It would be really nice to have you in it.
Why?
You have to-
That's how I get set up. So I'll find you all.
Even if it's a 1 o'clock, someone will look at that,
It's,
but I just.
yeah.
I can,
Even if the distance.
All right, I'm not doing anything you want.
Because the force.
Okay, cool. All right, thank you. Okay, we all agree?
Yes.
All right, let's do another one. Which one do you want to do next? Semicircle, and this one won't take as long because it's along the same sort of lines trying to figure out the length of the strip. So we won't have to spend so long reestablishing everything. It's still this. Force is equal to weight density times the depth times the area of a strip. And we collect it from one place to another as long as the strips last. This would be a picture of it if it were a semicircle. Do you want to do oil again? We could do seawater.
Let's do that.
Okay, seawater. And seawater's density is 64 point something, 4, I think.
Yep, that's great.
All right, I'll tell you a story about that if you want in a while. Okay, so what we're gonna do is we're gonna submerge that so that it's with the stuff that's underneath is a semicircle. And I'm gonna tell you that the distance from here to here, the diameter of it is gonna be 14 inches. By the way, the last one was in, I don't know what it was in, if it was in inches.
It was inches.
I know, but I don't remember what the final unit would be. It's not work, it was force, so it'd have to be in pounds. Okay, all right, so we got 14 inches there, and we want to know the total force on this if seawater's density is 64.4 pounds per cubic foot. That's all I get.
first part of the equation, which is just 64.4 times y. Yeah, times blank dy.
So 64.4 y times something dy, and the something is the length of the strip.
Yep.
Okay, and we're gonna integrate that, right?
Should we find the limits of the integration?
Okay, that would be a wise thing to do at some point.
Yes.
Which will just half the diameter.
So this right here is,
Seven.
Yeah.
so we'll integrate from 0 to 7. One thing left.
Inches.
What's that?
Oh,
Yeah, you're right. We should convert that. I don't think that happens on here. I think everything's in units that don't need converted. Okay, let's change this so that we don't have to screw around here. It's 14 feet.
Okay.
That is one heck of a plate. 14
14
feet.
That's what it is.
Because this is given in pounds per cubic foot, so that's 14 feet in seawater. Okay, so this is 7 feet down here, still 0 to 7. Now what? Gotta find the length of a strip. We got the dy part of it already. We need the length of it.
2 square roots of 49 minus x squared.
Okay.
I'll buy that.
How did you get that? That's the one.
Because that's like, that length is an arc.
That's an arc.
That's true.
Now we want to superimpose a grid on this. Where would you like to put the origin on this?
The bottom.
Right here? I would.
Yeah, put it right
I'd like to put the origin right there.
Yeah, that's a good idea.
Because that way I've got a circle that I haven't transposed anywhere. I haven't moved it anywhere. I don't have to mess with that. I've got the origin here. And it would be really nice to know this, right? Which means I need the equation of that circle. What's the equation of the circle?
X squared plus y squared.
And do I want to know the x value or the y value to help me with this area?
It doesn't really.
It does matter.
Well, it's still the same.
I wanna know the x value.
Do I want to know the x or the y?
Go to solve for x.
I want to know the x. That's from here to here, because that's the x coordinate of this distance that drops down to there. That's the x value and the y value. I'm sorry, I want the x value, and it's in terms of how deep it is. That make sense?
Mm-hmm.
And that's why John said it's twice that. That is the length of my strip. Yeah?
Because
We okay on that? So I would be doing 128.8 integral from 0 to 7 of y root 49 minus y squared dy. Ooh, that's ugly too.
all twos are beautiful.
You following that one?
You guys get 14,000.
Yes.
726.133.
14,000 what?
726.
14,726.
0.1333.
Point one is fine, but what's the unit?
Pounds.
Pounds. It's not work, it's force, and force is measured in pounds.
So we're always pounds.
In this problem, yes.
Because that's the total. So just
And if you're really gonna dip it into the middle, just push the thing down into the middle of the fluid, it would really be double that, because it'd be acting on both sides. But I'll give you that or double that, full credit, no problem. Depends on how you're thinking. Okay? What's the last shape we've got to submerge?
Square.
Not a square, or a rectangle. Keep that up there. Okay? You wanna push this one down into what? Oil? Crude oil? I don't know what crude's density is. We'll just say regular water, 62.4. There's the water level. We're gonna submerge a rectangle. A rectangle that is 12 feet across here and 8 feet down. You ought to be able to put this one together with no trouble at all. What are we integrating from and to? What's the weight density?
62.4.
How deep is the strip?
Y.
And what is the area of the strip?
12.
12
Boom.
dy. Do it.
Bam.
Because it doesn't matter what strip, it's going to be 12 units long. This is the easiest one of all. There's no equation to superimpose because all the strips are the same length. And they're all 12 units.
I think it's driving.
Probably gonna be triangle.
I'm hoping for circle.
No.
The hardest thing is.
You want the triangle? Circle would be.
Why would you want the
I
triangle?
want the rectangle.
Yeah, I want
Okay, listen to the words so that you know how to put this together. I will just superimpose one of those shapes. I'm not going to tell you which one. I'll just put all three shapes when it comes to that. So it will say something like this. A rectangle or semicircular or equilateral triangle metal plate with length and width given, length and width 12 and 8, or it will say with diameter 14, or it will say with a side length of 8. Oh, that's the next piece given. Is vertically submerged in a tank of something so that one of the level surfaces is even with the surface of the substance. If the substance has a weight density of, gives you that number in pounds per cubic foot, what is the total fluid force against the surface of the plate?
Are there any pictures for any of these?
No pictures. No
So
pictures.
like when it says vertically,
This is what the quiz looks like. No pictures.
It's just how we did it.
but when it says like vertically, would that mean that like?
It just dips like that, right around.
It just means you're pushing it in this way as opposed to this way. Well, that wouldn't make any difference anyway. They're just saying, you're gonna take this thing, you're gonna dip it in this far, what's the fluid force on the part that's under this fluid?
So what would happen if I was goober and I put like 12 as the depth and 8 as the length?
I think it might, because,
Then the depth would be
yeah, if you went 8 here and 12 here, you're experiencing more pressure down here. But on a smaller strip, I don't know. Check it out, see.
You can try to switch the flow.
Yeah, just go from 0 to 12 and change that to an 8 and see what you get.
So what?
So don't do that.
But how do we know?
It'll be very clear in the words.
It's not gonna. Test.
And then if it's not clear to you, you can bring it up and I will describe what they're trying to say.
Sweet.
It's not gonna be.
It's not gonna be Eric.
But if it is,
But it ain't.
Fear landed. This is under.
Okay,
Quiz.
that's quiz, and it's tomorrow.
Sweet.
Right.
yeah.
That was longer than I intended. There you go.
That's-
Yes.